Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to see one of the battery which is called lithium-ion battery. We are going to see the working principle, the construction of this lithium-ion battery and its applications. So, we are going to focus on the construction of the lithium-ion battery and working and the chemical reaction involved in the lithium ion batteries, next followed by the application. So where we are going to use this type of batteries, we are going to see in detail today. So coming to the introduction, so what is lithium ion battery? So it is a rechargeable battery which the chemical reactions involved in it are reversible. So once the chemical reaction completed, so it got discharged. Once the chemical reactions and the chemical present in it are active, then it is ready for the use. So which is nothing but the rechargeable batteries. So here these lithium ions are going to reduced in these batteries which store the energy. So that's why these lithium ion batteries are rechargeable batteries. So this is the lightest of all the metals, means this weight is very less and lightest material among all the metals present in the periodic table. So it has the greatest electrochemical potential and also provides the largest specific energy per weight. So this is considered, so this lithium is considered because of these unique properties among the other metals. So these properties make lithium the potential to achieve very high energy as well as the power densities in high density batteries. So the application of these lithium ion batteries are very useful in such as automotives and standby power. These lithium ions are play a crucial role. So here the coming to the construction of the lithium ion battery construction. Here anode as like other batteries like anode, cathode and electrolyte present in this type of batteries too. Here the anode is carbon compound or graphite we are going to use, and the cathode, coming to the cathode of a positive terminal, this lithium oxide or the lithium oxide or lithium cobalt oxide we are going to use as a cathode. Coming to the electrolyte, this lithium salt is used in and is dissolved in an organic solvent which we are going to use as a lithium solvent electrolyte. So coming to the applications, these are used in all the apparatus, all the, so we are going to use in all the electric appliances like laptops, cell phones, electric vehicles. These lithium ion batteries play a crucial role. So the cathode consists of a graphite which acts as an anode into which lithium oxide is intercalated. So here this lithium oxide is intercalated in the graphite rods. Here we can see this is the non-aqueous electrolyte which is the lithium. So here the electrolyte is LiPF6, means lithium hexafluorophosphate. Here lithium tetrafluoroborate we are going to use as a electrolyte which supplies the lithium ions. So that this reaction will happen. So these electrolytes acts as a source of lithium ions. So the membranes such as microporous polyethylene are also used to separate electrons from its ions. To separate the electrons from its ions, this polyethylene is used. So the intercalation, here we are going to intercalate the graphite with lithium oxide. So this helps in the small ions. This keeps the small ions into the interstitial spaces in a graphite crystal. We are going to insert these lithium ions in the graphite. Here we can see the graphite with some dots. So we are going to insert these. So we are going to insert these ions in the graphite. So this is the intercalation. The intercalation keeps the small ions into the interstitial spaces present in the graphite rod which is anode here. So what are the reactions going to happen in this lithium ion battery? Coming to the reaction involved in this, here during discharge, Means when the reaction during the process of discharge, means it is coming down, the charging is coming down, an oxidation Hopf reaction at the anode produces the positively charged Li plus ions. So at anode discharge process, so during the process of discharge, these Li plus ions are produced because of an oxidation of cell reaction is going to happen at the anode. So this produces the Li plus ions, which are nothing but lithium, positively charged lithium ions, and negatively charged electrons, and also releases electrons E minus. So the negatively charged electrons and the positively charged lithium ions are going to produce due to the oxidation half cell reaction at anode during discharging process. So the lithium ions thus produced move through the electrolyte. These electrons move through the external circuit and recombine at cathode. So thus produce lithium ions, and these electrons move towards the cathode, and again the half cell reaction, which is a reduction reaction. At anode, it is oxidation reaction. Here, the reduction reaction is going to happen at the cathode. So, thus formed lithium plus electrons, and which we are using cobalt oxide. So, the cobalt oxide going to react with the lithium and electrons, which results in the lithium cobalt dioxide. So, again at anode, what happened? This LiC6 is going to, which is the lithium intercalated anode. This intercalate anode is going to oxidize, means it is going to lose its electrons. So it results in the formation of C6, nothing but the graphite, and lithium ions, which are positively charged lithium ions, and the electrons, negatively charged electrons, are released at anode. Thus formed lithium plus ions and electrons are moved towards the cathode. Then it reacts with the cobalt oxide and results in the formation of lithium cobalt dioxide and lithium plus and electron formation. So the overall reaction here, if it is discharging, means left to right, here the anode to cathode, because during this process the anode reaction oxidation half cell reaction releases lithium ions, which is Li plus ions, and electrons, which move towards the cathode. There it is going to react with the cobalt oxide. So this is left to right discharging process. Here the reactions are, overall reaction is lithium graphite plus cobalt dioxide. Here these two, lithium C6 plus cobalt dioxide gives rise to C6 and lithium cobalt dioxide. So here the overall reaction it is. So coming to the another reaction, which is called charging. So the reaction during discharge lower the chemical. What happens at the discharge? It lowers the chemical potential of the cell. So discharging transfers energy from the cell to wherever the electric current dissipates the energy, mostly in its external circuit. So the overall reaction has its limits. Over discharging supersaturates the, so if it is drained, if the battery is drained too much or over discharged, it happens this lithium cobalt oxide, leading to the production of lithium oxide. So the lithium cobalt dioxide, which is LiCOO2, here this lithium COO2 is going to use the lithium oxide LiO2. So this is possibly by the following irreversible reaction. So this reaction is lithium plus, and so the reaction is lithium plus and electron, which is produced at the anode, which is going to combine with the lithium cobalt dioxide, which is LiCOO2 plus, which gives rise to LiO2 and cobalt oxide. So this irreversible reaction going to happen. So another reaction produced in the lithium ion battery is, in a lithium ion cell, the lithium ions produced at anode are transported to and from the positive or negative electrodes, either by oxidizing or reducing the transmission metal called cobalt CO in lithium cobalt dioxide. So it is going to change its state from +4 to +3 during charge and reducing from, so it is reversible. So suppose it is CO4 plus to CO3 plus during, this is during charging process. Here CO3 plus 2, CO3 plus during discharge process. Here the oxidizing, so it is going to oxidize in the discharging process, and again here reducing in discharge process. So the lithium ion batteries can be a safety hazard since they contain a flammable electrolyte which is called LiPF6, which is lithium hexafluorophosphate, and may become pressurized if they become damaged or some sort of insertion or some sort of pressure is applied on it. So a battery cell charged too quickly could also cause a short circuit leading to the explosion and fire hazards. So these lithium ion batteries can indeed catch fire. So the lithium ion battery can be started fire due to the following reasons. So the thermal abuse, because of it may be due to the poor cooling or an external fire, or any some thermal abuse may be due to heating also. So another one is the electrical abuse, which is the overcharge or external short circuits, because the electrolyte present in it is a flammable. So there is a possibility to catch fire, which is lithium hexafluorophosphate. So and also due to the mechanical abuse, because it may be due to the penetration or crash, or also due to applying the pressure on it, it may cause the mechanical abuse, and it should not be pressurized. So the internal short circuit, it may be due to the manufacturing mistakes or flaws, or also due to the aging. So the reactions of lithium ion battery during charging process. So these during charging process, these reactions and transports goes to the opposite direction. We have seen from left to right. Now the reaction is the right to left. We have seen the reaction from left to right, which is during discharging process. Here we are going to see from right to left. From right to left, which is charging process. Here, the electrons move from the positive electrode to the negative electrode through the external circuit. Here, these electrons will move from the positive electrode. Here, the positive electrode to from here to here, the electrons move. Here, to charge the cell, the external circuit has to be provided, which provides the electrical energy. This energy is then stored as a chemical energy in the cell. So at anode, lithium C6 is going to give C6 plus lithium plus electrons, whereas at cathode, cobalt dioxide, so which is present as at the cathode, is going to react with the lithium ions and electrons produced from the anode and gives lithium cobalt dioxide. So the overall reaction is LiC, the lithium intercalated graphite plus cobalt oxide plus graphite will give rise to lithium cobalt dioxide. This is the overall reaction. Here we can see the C6 plus electron plus lithium is the lithium gives rise to lithium C6, which is the reduction, and lithium cobalt dioxide, which gives cobalt dioxide, and electron plus lithium, which is called the oxidation process. Here we are going to supply the external current, so which we are providing the energy, electrical energy. Thus produced means we are charging. So thus produced electrical energy is stored in the form of is stored as the chemical energy inside the lithium ion batteries, which are called LIBs, lithium ion batteries. So the reactions of lithium ion battery is during charging an external power source, the charging circuits applies an over voltage, a higher voltage than the battery produces, of the same polarity. So the forcing a charging current to flow within each cell and from the positive to the negative electrode in the reverse direction of a discharge current under normal condition. Here we are charging. Charging means we are providing the external current, which is stored in the form of a chemical energy. So the reactions is from left to right and right to left. So that during discharging process one direction, and during charging process this is in opposite direction. So the lithium ions then migrate from the positive to the negative electrode. where they become embedded in the porous electrode material, which is called LiPF6 or lithium hexafluorophosphate. Also known as, this process is known as the intercalation of the electrolyte. So here, this how lithium ion batteries works in detail. We can see here. Here, the electrons are moving to here, and from the positive to the negative. So from left to right and right to left. So during charging process, it moves towards this side. So during this, here we can see the discharge process, the electrons movement over here. Here at cathode, cobalt dioxide plus lithium plus electron is going to give lithium cobalt dioxide. At anode, LiC6 lithium graphite plus gives rise to C6 plus lithium positively charged lithium ions as well as negatively charged electrons. So the overall reaction is Li lithium C6 plus cobalt dioxide, which is COO2, gives rise to C6 plus lithium cobalt dioxide, which is LiCOO2. So the reactions is left to right is discharging. So if it is left to right, this is discharging, and right to left, this is charging. Simple. So based on the movement of electrons from positive to negative, negative to positive, this charging and discharging process is going to happen in the lithium ion battery. So what are the advantages and disadvantages of lithium ion batteries? Coming to the advantages, it is very lightweight and have higher energy density than compared to other rechargeable batteries, and rate of charge is less, and also have a greater number of charger and discharging cycles. So even the battery life cycle depends on the number of cycles it is able to discharge or charge. So it also gives the capability of the battery. So need not to be discharged completely and operates at higher voltage than other rechargeable. So comparatively, it operates at a higher voltage. So what are the disadvantages? It involves the risk of burning because the electrolyte which we are using inside the battery is flammable. So also costly compared to the other batteries. So the complete discharge also can damage the property because the cobalt dioxide present, lithium cobalt dioxide is going to convert into lithium oxide. So it causes the interruption of the chemical reaction and extremely sensitive to high temperatures. So as we discussed it can catch fire due to the thermal abuse or mechanical abuse or maybe the electrical abuse. And also the lifespan is short, so not available in standard cell size. Those are the advantages and disadvantages of lithium ion batteries. So coming to here, these lithium ion batteries are a growing market. They are used in mobiles, laptops, and digital cameras and electronic cigarettes and these torches. Here, these lithium ion batteries are clubbed up with the polymer technology, and very small paper batteries are also in market now came into the existence. So lot of the research and development was going up on these batteries, which is the lithium ion is most preferable because of this is very light material, and compared to the other metals in the periodic table, it has a greater capacity or tendency to undergo the reduction and oxidation process. So it also used in power tools like cordless drills, saws, and garden equipment. So these are electrical vehicles or in automotive industry. The electrical cars, buses, forklifts, and auto bicycles use this type of lithium ion batteries. It is potentially a growing market for lithium ion batteries. LIBs is nothing but the lithium ion batteries, and it has the high energy storage and grid energy. Photovoltaics are also came into existence. We can see the cars, buses, forklifts, and auto bicycles. This lithium ion transportation, these batteries are used, and the gradually saturated smartphones and smart mobiles, smart watches, even laptops, which are rechargeable. So the tablets and these power tools which we use like cordless drills, saws, and the garden equipment, and also for the personal care like massages and these steam irons then portable energy storage and the renewable energy also in the grid energy and stationary energy storage. These LIBs is a potentially growing market and play a crucial role. So these the applications of lithium ion battery. They are small cylindrical solid body without terminals, such as those used in most e-bikes and also in the electrical battery vehicles, electrical cars, buses, and forklifts, and older laptop batteries. There are several standard lithium ion batteries in cylindrical sizes. So the large cylindrical solid body with threaded terminals. So they also available in flat or pouch, which is soft flat body, such as those used in cell phones and the now trending laptops. Means the recent type of laptop. These lithium ion polymer batteries, they come as like a pouches. So these rigid plastic case with large threaded terminals such as electric vehicles, traction packs are used, and the application we can see here. Here this is the anode current collector. Then this yellow one is the lithium and the solid electrolyte separator and cathode active material, and which is active material and cathode current collector. So this is available in the pouch cell. So these pouch cells are multiple pouch cells make up battery. Again, these module of solid state lithium ion batteries are used in e-vehicles, electrical vehicles. So here once it is charged, the reaction from left to right, again discharged from right to left. So this chemical reaction is going to activate it by the supply of the electrical energy. Here lithium ion battery, an electrical vehicle is powered by thousands of lithium ion batteries like this. So they are packed in a grid module. Here thus they are used like this. So module of lithium ion batteries, and they are used in e-vehicles. It may be buses, forklifts, or e-cars. So the applications of lithium ion batteries in electrical vehicles. This is the structural battery cell. Here we can see this is used as a layer on it, like air vehicles. This concept is gradually being incorporated into the vehicles that are already on the road. So the Tesla, one of the famous company, has designed a new structural battery that will directly attach to the seats inside of its model vehicles. So it is a growing potential market. These lithium ion batteries play a very crucial role, starting from the smartphones to the electrical vehicles. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.